So good afternoon, my name is Michael Brown. I am a doctoral student at the University of Michigan in the School of Education. And the study that I'm going to talk about today is part of an ongoing project in the Learning, Education, and Design Lab at the University of Michigan with a group of scholars from the School of Education, the School of Information. In particular on this project, I work with DeMonbrun and Stephanie Teasley. And what we're interested in part, if you heard Dr. McKay's keynote the other day, is to capitalize on all of this data that's being produced in that digital innovation greenhouse. We're developing a lot of tools, and through the use of these tools being deployed in large classrooms, we have very big data sets about student behavior with lots of N's, right? And we wanted to start to look at some questions that on a scale that we couldn't previously. So this is actually the second time we're closing LAK. I don't know what that means. We're always the pinch hitter. But in a prior study, what we looked at was how students in the first year encountered academic difficulty in terms of timing of assessments in the curriculum. And what we found was that there were particular points in the semester after which students were very unlikely to recover. And in particular, those were in science, technology, engineering, and math classes, and they tended to be around the 8th week of the course, so the second midterm. If students haven't started to improve academically in a class by the second midterm, they were very unlikely to do so, and their odds of recovery decreased every week that passed, right? That they didn't start to show some benefit. So what we wanted to do was take a lot of these tools that Michigan has been developing that record behavioral engagement of students in different study strategies, map that out over the 18-week period, and see if there were different types of behavioral engagement that coincided with the progression of the curriculum and student engagement in their coursework over time. So what I'm going to talk about today a little bit is this idea of academic recovery, which is something that we're really starting to dig into with these tools, right? We have lots of historical data over the last 2 or 3 years about what students have been doing in their classes through digital systems. And we can start to see, in part because we have gradebook data and we use an early warning system, when students encounter academic difficulty and if they're able to recover. And then I'm going to talk about the specific design of this study, what we observed, and some implications for teaching, some implications for what we know about learning, and some implications for future research. So as I said, in terms of the timing of assessments, students' ability to recover academically was significantly related to when they encountered difficulty in the class. And if you really think about that, that's actually a pretty intuitive finding, right? If I start to underperform late in the class, I have less time in which to recover academically, right? So if I do poorly on the first exam, I have a lot more of a window in which I could make adjustments to my strategies, I could reflect on what I'm doing, and I could seek out new help resources. If I do poorly on the second exam, or the third exam, or the fourth exam, the likelihood that I'm going to have time to sort of adjust my strategies before those final high-risk assessments, that window is increasingly smaller. What we also found was that students tend to rely on study resources that they believe will provide them future information about their performance. So in particular, practice exams was one of those resources that students were very likely to access through a learning management system, and that using the study exams, while it was related to higher levels of performance, wasn't necessarily, we wanted to understand if it was related to recovery, right? Was this a strategy or one of the strategies that students were adopting later in the course that allowed them to recover academically? And what we also observed is when you get into these classes, which at least in residential education, you know, learning at scale for us means 100, 200 students in a classroom, students enter the classroom with lots of different motivations and lots of different goals. Their goals might change over time, and because they have different motivations and different goals, their pathways through the course to get to where they want to go are all going to be very different, right? So if I'm somebody who's in a high-risk class, it's super important for my major, and I start to get performance information late in the course that I'm not doing well, I might be much more willing to dedicate time, energy, volition into recovery strategies for that course than someone who's just taking the course to pass, right? Or someone who's taking the course to fulfill a requirement. And so we wanted to see, when we looked at lots of different students from different majors in these sort of first-year gateway courses, did their strategies look different over time? So we focused in part on one class because this was meant to be kind of a proof of concept to see if we could do this for more than one class at the university. And we focused on a class where we understood the instructional context particularly well. So this is an introductory statistics course. I'm saying at a residential research university, but it was at Michigan, in the United States. And we focused on this course in part because we'd done prior research there. And so we knew when assessments were timed, what kind of expectations the instructors brought into the classroom, what kind of things they told students. This class used a number of the resources that have been developed through the Digital Innovation Greenhouse. It is also the largest course at the university. Every semester, it enrolls 2,000 students across 4 sections. The course is primarily second year or sophomore students in our parlance, although there's a good percentage of third and first year students. And this course is a requirement for a number of majors at the university, not just STEM majors, but a number of social science majors have to be successful in this class to be able to progress in their degree program. So on some level, it's a high-risk class for a number of students. For the population that we focused on for this study, we wanted to identify specifically students that experience some academic difficulty, and I'm going to talk about what I mean by that, at some point in the course, which was only about a quarter of those 2,000. It was a little over 500 students. So we had 2 research questions that we went into this study with. The first was, do students' learning technology adoption precede, coincide with, or lag their experience of academic difficulty in the course? Because of trace log data, we can very easily go in and see when students started using a tool. We also have some measures that we've developed that we would consider intensity use. And so we could start to see it's not just are students adopting this, but are they regularly using it as part of their practices? And where does that relate, and where does that use relate to when they experience academic difficulty in the course for the first time? And then we developed a hazard model to look at what factors significantly increase students' odds of improving from academic difficulty. And so we use these 2 classifications that are assigned through our early warning system. An Explore classification, which means that a student's experiencing moderate academic difficulty, or an Engage classification, which means they're experiencing severe academic difficulty. And this is how we define that. So we use a system called Student Explorer. It's a little bit hard to see, but essentially in the first step, students get a calculated grade in the course from the grade book. If there are no grades in that week, if the instructor hasn't started to hand out assessments or assignments, there's no classification. In the second step, we look at that student's grade relative to, is it mean or median? Stephanie? Mean? Relative to the mean or the average performance in the course, right? Is the student above the average or below the average? And the next step, we look at their learning management system use. How frequently are they logging on? The only time that we actually use the learning management system to classify a student is when they're on a border case, right? So are they really clear to be close to being either an Explore student or an Encourage student? If they're below the average LMS engagement, they move into the lower category. If they're above it, they move into the higher category. And so every week, a student is given one of these 3 classifications, either Encourage, which means that they're doing well, Explore, which means that they maybe are sort of on the border of average performance, and then Engage, which means that this is a student who's experiencing some substantial academic difficulty. So we take this weekly data and we pair it with student log use of a tailored coaching system that's used in the class called eCoach, which again, if you heard Dr. McKay's talk, you're probably pretty familiar with this. And as well as a practice problem tool called Problem Roulette. And so students, these tools are structured in slightly different ways. Problem Roulette is just a website that has statistics problems that you can go on. They're multiple choice, do it whenever you want. The sort of prototypical use case is a student sitting on the bus, waiting to go to campus, doing practice problems on their phone. I can't imagine the scenario where you take out your phone and you're like, let me do some stats, but I've actually seen it happen. So there's the other tools, there's a grade calculator in the course where students can input the information they have about their performance, input what they expect to do on future assignments and see what their grade might be for the class. there's a checklist called Get Things Done, which is written by the instructor, and it's a series of tasks that students are encouraged to do every week that if they engage in, the instructor believes will improve their performance. There's a weekly help and advice message that comes from the system. And then there's two tools that are only released in the period right before exams. One is called Name That Scenario, which is also a problem review tool, but it's a little bit more in-depth and involved. There are sequential problems that increase in difficulty, and students have to progress through them and get more feedback from the system when they don't do well in the tool, and what we call an exam playbook. So students can complete what's called the exam prep tool before the exam. They tell us what they're going to do, when they're going to do it. You know, that example where the Google Calendar comes up and students can plug in their study behaviors, that's from the exam playbook. And then there's a review tool that after the exam, it asks them what did they actually do and what would they do differently on the next exam based on their performance. And so in the model, right, the ongoing tools are weekly covariates, and the Name That Scenario and exam playbook are sort of fixed covariates because you can only do them in specific periods. So when we looked initially at how students use the tool over time and when they adopted it, we immediately saw substantial differences between the students who were sort of in that encourage, you know, you're doing great classification versus students who experience academic difficulty. So this is the percentage of users who read the weekly advice messages in the system. And as you can see, the encouraged students, and you can probably guess when the exams are in this class, but about 80% of the encouraged students almost always read the weekly advice messages in the period before an exam. A much smaller percentage, about no more than 50% in any week of the Explore and Encourage students were reading these materials. So even before they started to experience academic difficulty, we started to see on average trends in their behavior. This was also true in the exam playbook. Very few of the students that experienced academic difficulty at some point in the course used the prep tool for the first exam, but a substantial number of them used the reflection tool after the second exam. And so that was also the exam where most of these students started to experience academic difficulty. So what we think happened here is that they got a bad grade, then the exam reflection tool came up, and they were trying to figure out what they were doing wrong, and they used the reflection tool as a way to start to think about how they might change their strategies. So in terms of the statistical model here, we used a discrete time hazard model. The outcome is whether a student in any week improved academically from one of the two classifications. So what was the odds or the likelihood or the probability of a student who had experienced academic difficulty in that weekly period improving from I don't want to say poor, but less than ideal classification to an improved classification. And so students had to at some point be classified, engage, or explore to be included in this model. That's why there's only 500 students out of the 2,000. So when we looked at students who had entered explore and improved, right, these are students that were experiencing moderate academic difficulty, what we see is that they're using tools that promote self-regulation of their learning, right? The tools that made a significant difference were using the exam prep tool, which helped them think about and plan their study strategies for the exam. And then the Get Things Done checklist, which was literally just a list of things that they could check off every week. And if a student went in and checked off one of those boxes, they were 6 times more likely to improve in the following period than students who didn't use the tool. So in contrast, when we look at students who were experiencing substantial academic difficulty, what we start to see is the tools that made a difference here were things that helped them review the course material and the concept and practice applications of the course material. So problem roulette, students did slightly better if they did at least one problem in the problem roulette system. Students who used the exam prep tool before the exam were also likely to improve in the subsequent week, and then students who use the exam reflection tool were also likely to improve in the subsequent week. So what does this mean? I think the first thing that this suggests to us is that we want to pay close attention to students' resource use behaviors early in the semester. We saw differences in the pattern of adoption and use over time before students even encountered academic difficulty that probably were pretty good predictors of whether they would actually experience academic difficulty. So we want to consider the salience of the failure to adopt early in the course for their potential ability to recover. What we didn't see a lot of was somebody having academic difficulty and then adopting a tool. What I observed a lot of in this data set was students who adopted the tool early on, were sort of using it, experienced academic difficulty, and then made changes to the strategies that they were already engaged in. So this isn't a lot of starting from scratch and improving. It's a lot of like testing things out, getting bad assessment feedback, and then starting to think about what you should do differently. As I said, adoption decisions, they happen relatively early in the course and they appear pretty sticky. We didn't see a lot of students who just abandoned a tool or adopted a tool that was completely new to them. So the other thing that we wanted to think about in terms of design was that our early warning system doesn't flag any of these tools as something to think about when we're classifying students, but we see some evidence that the patterns of adoption that we see here are significantly related to performance at the end of the course. So it may be something to think about as we're further iterating Student Explorer, how we incorporate this trace data that we have about students' behavior in the system. So in terms of implications for student success, one of the things that we've immediately suggested to the instructors, and they've started to do, and we've actually seen a substantial difference in the behavior and use, is that they should address the importance of adopting these different study tools early and often. So initially in the course, the instructors would introduce them in the first week of class, and then kind of never return to them. And now after each assessment, the instructors are going through the tools that are available to students, describing them, describing how you access them, and giving students some suggestions for how they might be using them in the future. So when we're thinking about pedagogy, right, and we're thinking about sort of what we want students to be doing in this classroom, we might want to think about ways that we would treat these material practices not as individual tools that sort of have a binary use, but that as a set of concurrent interactions that students are engaged in and that the technology in turn might have a performative effect on the student through its use, right? The other thing that this study further underlines is that these learning analytics approaches can help us observe those complex interactions across time and space in educational contexts. One of the things that's interesting about this course is that it's sort of blended, right? And it's sort of a residential course because it's so big. They record the lectures, and so students don't go to the same instructor every time. They watch the classes sometimes in their apartment, but sometimes they come to class. We saw a lot of students who came to class and then would go home and also watch the video lecture. And the learning analytics data allowed us to capture those behaviors in a much more complex way across time. And then when we think about academic recovery in these classes, what we're really seeing is not so much a comeback. We're not seeing a student kind of make a U-turn in how they were approaching their study behaviors. What we see is sort of these slight modifications to what they're already doing, right? And they're making some kind of cost-benefit decisions about what's available to them, what they see that's productive, and revising their strategies for the future. So in terms of implications for future research, as I said, this was kind of a pilot study for us. And what we want to do is start to see if we can find similar results in either different disciplinary or institutional contexts. Michigan is a very specific context. I'd like to see what this would look like if we did this at an open access institution or at a community college. And I'd also like to see what this would look like outside of a statistics class. There's a whole set of cognitive and affective factors that we just didn't account for in this study that I think is significantly explain probably a lot of what's happening with students when we see those strategies change. And then I should say with a caveat, the instructor in this statistics course is very, very good. They're a very good teacher. And it is hard sometimes to reproduce results that you find in instructional contexts where the instructor is very good because you move into another instructional context and that instructor is not as good, and that's affecting the learning in the classroom. So we want to think about how to translate the study into different spaces where the curriculum's organized differently and the delivery of information is probably not as effective. So to conclude, we wanted to acknowledge and thank the students. This research was supported by the Learning and Education Design Lab at the university. And there's a number of folks who provided us formative feedback on this study. So thank you.
Any questions, Michael? But you maybe consider students' previous experience with this tool. how that would affect whether they will return to using this tool or not. Did you maybe take it into account?
Yeah, so one of the things that we want to look at.
I'm sure no one can hear the question.
That's a good point. So the question was about whether students had previous experience with the tool. A lot of them did, right? A lot of them were prior users. These tools are widely used in the introductory courses at the university, and because the majority of them were sophomores, they'd use these in other courses in their first year. In this model, we didn't account for it. We ran a slightly different analysis in an engineering class where we did account for it. And what we found was that there wasn't a benefit for people who had already adopted the tool in terms of adoption, but there was a benefit in terms of final grade performance. And I don't really know how to explain that result. It's something we're struggling with. What we may be seeing here is not so much that there's difference in terms of like behavioral engagement as much as like self-regulation. Right, and because we didn't look at those cognitive and affective factors, that's sort of like the next question for this study, right? So, thanks.
Michael, I was curious on your thoughts about the potential impact of the statistics curriculum on your findings if sometimes more difficult conceptual materials in statistics are later in a course sequence. Yeah. Could you speak to that?
Yeah, so that's a really good point. This is a heavily scaffolded course, and the difficulty increases exponentially with each topic, right? So this course is organized around kind of 4 modules. The first module is largely about descriptive statistics, which students generally have an easier time with. And the first exam, the median score on the first exam is really high. So part of what we see here is that students enter this class and they're a little bit overconfident in predicting how they're going to do in the future in the class. And then that second exam, which is where you saw the change in the exam reflection, that's really when you start to get into things like standard deviation and more complex statistical concepts, and also things that doing them mathematically by hand are much more difficult. You're much more likely to make an error. I don't know if anyone's ever calculated a standard error by hand, but it's a pain in the butt. And you don't carry a 0, you know, you're in trouble. So yeah, that's absolutely something we saw in the course, right? Part of the reason we used the hazard model was because it really only starts calculating probabilities around the time in which students entered academic difficulty, right? So if you look at the full paper, what you'll see is that we have a lot of change in probabilities, but they're over a very short window, and that's because they start around the second exam. There are very few students who are experiencing academic difficulty before the second exam. That's also why I think looking in other disciplinary contexts would be interesting. I would guess in a lot of the hard science courses at a research university like this, you'd see similar kind of scaffolding of topics. But there's certainly a number of other courses that are large, right, where the difficulty doesn't sort of exponentially increase with each exam. So, yeah. Yeah.
One more question.
Can I add an explanation to that too? The other thing that's interesting about this course is the instructor allows every student to throw out 1 grade. So if you do really well on the first exam and you don't do so well in the second exam, you have this extra incentive to try to figure out how to do better on the third exam because you have an opportunity to throw out your second grade. So you're not completely sunk with that second grade, which is, I think, why you see students start to change strategies, because they don't want to fail the third exam because they don't get to throw out 2. Right.
Although it's worth noting in this analysis, we don't include that because there was a weird epidemic of something on campus and almost all the students missed the second exam. So there just wasn't a second exam in this class. They were passing around the flu or something. And, yeah, sorry.
Great presentation, Michael. Quick question. I'd actually just want to know more, when you were talking about the instructors sort of indicating or pointing the students towards the tool, how much detail and demonstration did they give us to how to use the tool and use it? You know, and have you seen that the detail and depth that they demonstrate the tool now is more because I can see the benefit?
Yeah, so before we kind of did this analysis, what they were generally doing was going through the syllabus, right? And part of reviewing the syllabus was, here's these 5 or 6 tools that are part of the class that you can use. And now what they've started to do is in the discussion sections with the teaching assistants, at the beginning of each discussion session, the teaching assistant will sort of do a demo for the tool in the first 2 weeks, because there's not a lot to cover in the first 2 weeks in those discussion sessions. And we could sort of, without knowing when these demos are being done, I could tell you, because I can see in the data where the spikes are about adoption. And what's particularly interesting is that I think a lot of these students, from just anecdotal conversations, a lot of these students assumed that early material was not going to be in these tools, that like the stuff that you would cover in the first 2 or 3 weeks was almost too simple to merit being put into these study tools. And when they see that it's in there, they start to use it much earlier and with greater frequency. So, yeah, thanks.
Let's take our speakers on the time. And